Okay, this is question 3. It's called transportation. Again, it's one of the major questions. There are 4 cities. There are 3 cities here. You go from these cities, this is your from, and this is your to. So I'm gonna number them. This is 1, 2, 3, 4. 1, 2, 3. So you can go from Truro to Montreal to Saskatoon to Calgary. So you can go from any city to any city. And then they tell you you're going to ship each kilogram. So a kilogram going from Truro to Montreal costs $18. From Brampton for Saskatoon, 21. Victoria say to Saskatoon, 23. Now, the way we do this, we call the from usually I, and we call this J. There are 12 variables here that you need to define. X11 would be number of kilograms going from Truro to Montreal. This would be going from 1 to 2. This is 1 to 3. This is 2 to 1. This is 2 to 2. This is 2 to 3. This is 3 to 1, 3 to 2, 3 to 3. This is going 4 to 1, 4 to 2, 4 to 3. But instead of defining 12 variables, we can do them in one sentence. You can do it this way. Let Xij be number of kilograms shipped from city I to city J. And you can define I by saying 1 equals Truro, 2 equals Brampton, till the end, and J, say 1 equals Montreal, Saskatoon, Calgary. So you do this for both of them when you define the variables. Good? Now they tell you need to minimize your cost. To minimize cost, you know that the first one would cost $18, then $17 for the second one, then $26 for the third one, $19 for this, $21 for this one. You do this till you get to the end, 28 for the last one. Then they tell you in the question what they tell you in the question will help you determine what your subject to is. So for example, if you're coming from the 4 cities, this city is capable of providing 1850, or that's what they have available. So we start from available Truro. You ask yourself, what do we have coming from Truro? We have X11 coming from Truro, 1, 2, and 1, 3. They can provide this, so what's coming from Truro not to exceed 1850. Now, city 2, Brampton. Coming from Brampton would be 2-1, 2-2, 2-3, not to exceed what they're capable of providing. Regina. Coming from Regina, 3-1, 3-2, and 3-3, not to exceed 1700. And finally, Victoria, x41, 42, 43, not to exceed 1800. Now, doing the same analysis, but for the requirement. Required by Montreal. So required by Montreal, they need 2,800. You ask yourself, going to Montreal, what do we have going to Montreal? We have X11, 21, 31, 41 going to Montreal. They need this. We need to satisfy what they need. Must be at least 2,800. Required by Saskatoon. Going to Saskatoon, we have 1, 2, 2, 2, 3, 2, 4, 2. They need at least 2250. Required by Calgary, going to Calgary would be 1, 3, 2, 3, 3, 3, 4, 3. They need 1850, and again, all variables greater than or equal 0. Now this is it for this question. I want you guys to read question 4. And there are a lot of details in question 4. It's a long question. So read it carefully, and then we'll talk about it. So if you pause this video, read it, read the entire question, and then we'll talk about it. So basically, this is a company, they make 2 types of sofas. One is called the love seat and the daybed. They tell you they can produce this either in the first quarter, second quarter, third, or the fourth. There is a certain cost associated when they produce them according to which quarter they decide to produce them in. They also tell you they can store them in storage or inventory. To store, they tell you that it costs $200 to store them in inventory. And before the start of this, they have 15 love seats and 23 sofas stored. They want to have 22 of both of them at the end. They can only have 2, 3, 5 sort of in each quarter and develop. So this question is called production inventory. And usually there are a lot of details involved for production inventory. First of all, since they can produce in 4 quarters, they can store in 4 quarters, that means that for each variable, whether it's the love seat or the daybed, there are 8 variables, so meaning there are 16 total variables to define. This is how we define it. Let LQ, let's do it this way. Let LP1 be number of love seats produced in Q1. LP2 in Q2. LP3 in Q3. LP4 in Q4. Let LS1 number of love seats stored in inventory Q1. S2, 2, 3, 4. This is only for the first variable. To do the same for the second variable, we go DP1 Now, David produced in Q1. DB2, 3, and 4 produced in 2, 3, and 4. S1, 2, 3, and 4 stored in inventory Q1, 2, 3, 4. So these are the 16 variables necessary for this question. Then you read the question to see whether it's a minimum or a maximum. They tell you at the end, lowest possible production and inventory cost. So it's a cost question. So I'm going to read the variables. Remember the P for producing, S for storing. So you're minimizing cost. Now, according to the table, producing a love seat, you see the third line in the table? They also spell it wrong. They say love seer. So the love seat production in the first quarter, 1,800. So it's 1,800 to produce an L in the first quarter. Then it's 1,500 for an LP2. Then it's 1,400 for LP3. Then it's 1,200 for LP4. What about producing the D? Line 4, it's $900 to produce a D. $750 to produce a D. $700 to produce, and $600 to produce D4. Now they tell you this is production. What about, they told you in the question it's $200 to store your inventory. So that would be 200 to store an L in the first quarter, to store an L in the second, in the third, in the fourth, and 200 to store a D in the first, 200 to store a D in the second, 200 to store a D in the third, and 200 to store a D in the fourth. So that's your minimum. Now let's see if we can put everything together for the subject two. The first thing they tell you, you have 15 already in inventory for S, you have 23 for the daybed, leave them for now. You need to have 22 at the end, okay. And they tell you you have to have 235 each quarter. Also looking at the table, you have the last line of the table tells you production capacity. So production capacity is 4,900, and that's for both of them. So I'll consider this production Q1. Your production capacity for first quarter is 4,900. You can produce L, you can produce a D, not to exceed your capacity of 4,900. What's your production like quarter two? You can produce into L, you can produce a D, not to go over 5,100. Q3, you can produce L, you can produce D not to go over 5,300. And for Q4, you can produce L, you can produce D not to go over 4,500. That's your production capacity for each quarter. Let's look at the inventory. They also tell you you can only have 235 each quarter. So inventory Q1. So in Q1 you can only have 235 maximum. So whatever you store, so you can store L, you can store debit not to go over 235. Inventory Q2, you can store L, you can store D not to go over 235. Q3, you can store L, you can store D not to go over 235. Q4, you can store L, you can store 4 not to go over 235. What else? Now we get into what's called demand. How you can satisfy the demand at each point of time. Demand Q1. So each one of them has a demand. So we have to do this demand of the love seat Q1. Okay, watch how I'm gonna do it. You need to understand the concept here. This is production inventory. It's a little bit complicated. The demand, they tell you that's in the first line of the table. A love seat demand is 3,200. After the table, 2 lines after, they tell you have 15 love seats. So you enter this quarter with 15. You can produce some, so you can add more love seats produced. Minus, you can store some of the ones you produce. But whatever you do, you need to satisfy the demand. And the demand here is 3,200. This is how you satisfy demand for love seat Q1. Demand Q2. Now you enter Q2 with some stored from the previous quarter. So you have some stored from L from the previous one. Plus, you can produce some and then you can store some of what you produced, and that must satisfy demand for Q2 to 4,800. Demand Q3. You enter this with some stored from the previous month. You can produce some, you can store some, and that must satisfy demand of 3,100. Demand Q4. You have probably some stored, you can add, minus you store some, minus they tell you gotta have, they want to have 22 of them at the end. So you need to have 22 at the end. That's what they tell you. And this must satisfy demand of 5,400. And we do the same for the second one. Demand debit Q1. They tell you, you enter this queue with 23. So here 23 you have for the debit. plus you can produce some, you can store some, and whatever you do, you must satisfy the demand, and for this one, demand is 2,500. Demand Q2. You probably have some stored, you add production, minus you could store some, and that must satisfy demand of 2,600. Q3. You have some stored from the previous, you can add production, store some, and that must satisfy demand of this month, and that's 2,400. And finally, Q4, you have some stored from the previous month, you can produce some, store some, you gotta have 22 at the end, and this must satisfy demand here, and it's 2,300. This would be all for the question. You don't need to do anything. Oh, well, you always have to say all variables must be greater than or equal 0. There's another question, and that's not to hand in, it's more like practice. I'm not gonna do it now, but I'm probably thinking of doing something for the final exam. I still don't know how I'm gonna help you with the final exam, but I'll figure out a way. Once I decide how I'm gonna do it, I'll let you guys know. Okay? Good luck.